Welcome YouTubers to another episode in my Grammar Hero series. In this video, I'm going to be discussing the TABE, that is the Test of Adult Basic Education. In particular, I'll be working out problems on the math computation section of that exam. In case you don't know it already, the TABE is an exam many people take to gain admission to technical programs as well as law enforcement academies. And it's a test that's broken down into 4 sections, namely reading, language, math computation, and applied math. As far as the sections themselves go, you're allowed to use a calculator for applied math. And apart from that, you have to rely on your arithmetic skills to do the math computation section of this exam, which is what I'll be talking about today. Similarly, there are 2 versions of the test that you can take. You can either take a complete battery, which as you can see has about twice the number of questions as the survey and takes about twice as long to complete as well. All told, I think the battery takes about 4 hours to complete, whereas the survey takes about 2 hours to complete. As far as the math computation section goes, I want to note that you have to work fairly quickly and accurately on this section to finish it. As you can see, you only get 15 minutes to complete 25 questions, and again, that's without a calculator. In this video, I'm going to take things nice and slowly because I know some of you have not seen this subject matter in a long time. But as you practice on your own, you want to be mindful of the fact that for this section in particular, you have to be moving quickly. I actually pulled this practice exam from Lake City Community College. Here's a link to it down here. And similarly, I'll post a link in the video description as well. That said, let's get started. And again, I'm going to take things slow just to, make sure those people who haven't seen this math in a while are going to be able to follow along, okay? And this is the first time I've seen this material, so if it takes me a while to figure out a problem, you'll know that that's the case. So we'll start with number 1. Again, we're not using a calculator, so I'll do all my scratch work, all my work on the side over here. Number 1 says add 53 to 6,248. They're trying to trick you by placing the 6,248 on the bottom. So up here, I'm going to rewrite it. 6,248 plus 53. Then it's just a matter of adding up and down. So 8 plus 3, 8, 9, 10, 11. We bring a 1 up here since there's a 1 carrying over. 4 plus 5 is 9. Add 1, that becomes 10. We have a 1 that carries over. 2 plus 1 is 3. And we add nothing to the 6. So 6,301B. Okay. This one's set up nicely for us, so I'll just use what they have here. We're taking 1,283 and subtracting 621 from it. So 3 minus 1 is 2. Okay. And as I do these problems, I like to refer to the answers because one trick to doing exceptionally well on this section is to look at the answers and eliminate obvious choices that are obviously wrong. And as we can see, the last digit over here is 2. We have a second digit that's 8, whereas all these are 6. So if we get an 8 here for the second one, we can immediately stop. 8 minus 2 is 6. So we know this one's wrong. Now, there's 2 ways you can look at this one. You can look at it as 12 minus 6, in which case it would be 6. Or you could do 2 minus 6 and bring the 1 over. I look at it as 12 minus 6, so 662A. Okay. Again, this one's straightforward. They didn't write the bigger number on the bottom, so there's nothing to rewrite. That said, we have 134 minus 89, so we're going to start on the left and work our way to the right. We have 4 minus 9, so we're going to have to borrow from this 3. This 3 is going to become a 2. This 4 is going to become a 14. So now we have 9 minus 14, okay, which we know is going to be 5. Now we have 2 minus 8. Again, we can't take that away, so we got to make this 1 a 0 and add a 1 here. So it's 12 minus 8, 8, 9, 10, 11, 12. So 4. So we know this one's 45. I apologize if that's too small for you to see. For problems that are more difficult, I will be working them out on the side here. 10 times 16. I'll work this one out on the side since people may not have seen it in a while, and I want to familiarize them with long multiplication. So we got 16 times 10. As far as long multiplication goes, you take the digit in the bottom left, multiply it by top and bottom, bring down a 0, take the digit here, multiply it by everything in the top row. So 0 times 6, 0, 0 times 1, 0. We drop down a 0 because we're going to a different number. 1 times 6, 6. 1 times 1, 1. We add these, 160. Okay? Many of you could have solved that without doing the work, but again, I'm just doing a refresher for those people who need it. Okay? Long division, 2100 divided by 84. Basically, what we're trying to do is find a number by which we can multiply 84 that will give us 2100. Okay? So let's go ahead and, in this case, what I would say is be mindful as you plug things in. 100 times 15 would be 1500, so we know this one's not going to work. 100 times 25 would give you 2500, so this one might work. So the rest of these are still in play. So let's go ahead and work them out one by one. Instead of doing the division, I'm just going to take 84, multiply it by these 3, and find which one's right. So let's start with 25. 84 times 25. Again, 5 times 4 is 20. Carry the 2 up there. 5 times 8 is 40. Add the 2, so we got 42. Bring down a 0 since we're starting a new row. 4 times 2 is 8. And 8 times 2 is 16. Add them. 0 plus 0 is 0. 8 plus 2, or 2 plus 8 is 10. Bring a 1. 6 plus 4 is 10. Plus 1 is 11. So we bring down that 1. So this is 2100. What were we looking for? 2100, so we're done. 25 turned out to be the right one. Okay, now we're adding decimals. The key to this is lining up your decimals and then adding up and down. As you can see here, they try to trick you by not aligning it well. So let's go ahead and do that. We got 5.4 and 3.073. Okay. Now that we have our decimals lined up, we can go ahead and do this one. Again, there's imaginary zeros here if you don't see anything there. So 0 plus 3 is 3. 0 plus 7 is 7. 4 plus 0 is 4. Bring down our decimal. 5 plus 3 is 8. So we got 8.437. Boom. A. Okay. Subtraction with decimals. And as we can see, we got 5 minus 8, which we can't do without borrowing. So to make the work nice and neat, I'm actually going to do it off to the right for you so you can follow my steps. So again, we got, and I'm going to carve out a little square here for us. 7.45 minus, and I'll 0.38, and as you can see, I lined everything up. 5 minus 8's not doable, so we got to borrow this 1 from this 4. This becomes a 3. This becomes 15. 8 goes to 15 how many times? 7. Or 15 minus 8 is 7. 3 minus 3 is 0. We bring down our decimal place. 7 minus 0 is 7, so we get 7.07. Okay. Multiplying decimals, there's a trick to this that I'll show you, and again, I'll work it off to the side. And they're really crushing us with this arithmetic. So we got 950.3 times 7.4. The trick is to make these decimals into whole numbers and remember how many decimal places you had to move and then add those decimal places back in at the end. So I'm going to move this over 1 to here. That's 1 decimal place to give me 9,503. And I'm going to move this decimal place 1 to give me 74. So I moved 1, 2 decimal places. Okay. At the end, I'll add those back in. So now this is a simple multiplication problem. 4 times 3 is 12. Bring the 1. 4 times 0 is 0 plus 1 because we got the 1 hanging out there. 5 times 4 is 20. So we bring down the 0. We carry the 2. 4 times 9 is 36. And then add 2, 38. Okay. Drop down a 0 since we're starting a new row. 7 times 3 is 21. So we got to bring a 2 here. 7 times 0 is 0, and then add the 2. 7 times 5 is 35, so we bring the 5 here. We add the 3 here. 7 times 9 is 63. Add the 3. 63 becomes 66. Add them. We got 2. 2 plus 0 is 2. 1 plus 1 is 2. 0 plus 2 is 2. 8 plus 5 is 8, 9, 10, 11, 12, 13. 3 plus 6 is 9. Add 1, that becomes 10. Carry the 1, 7. Okay, so again, I took away 2 decimal places. So at the end, I'm going to put my decimal place here, move it over 2. 1, 2. So it becomes 7,032.22, which is right there. Okay. Dividing decimals, not surprisingly, also has a trick to it, and I will show you how to do that on the side here. So we got 2, 5, 3.356. And we're dividing that by 2.58. I sure hope these get less tedious. But as you can see, you have to be confident with multiplication, division, long division, add, addition, and subtraction to do well on this section. Okay? So the trick to this problem is to make this one a whole number, and the number of times you move this decimal place, you simply move it over here too. So I am going to move this one twice to make it 258, And since I did that, I'm going to move this one twice and bring the decimal place right up here. Okay. So basically, make this one a whole number, adjust the decimal place over here accordingly. Now, if you look at our answer choices, you can see that we have a few: 89, 96, 98, 98. Now, I like to do the least amount of work as possible, and as I did in one of these, I multiplied the answer choices by the divisor, the number we're dividing by, to find which one is correct. So if it turns out that 98 will get me this number, I can cross these two out automatically and just work with the decimal places over here. So that's what I'm going to do. I'm going to start by multiplying 258 by 98 and see what that gets me. If it's less than 25335.6, we know we can use 98. So let's go ahead and do that. We got, again, 258 times, I said 89. We're not going to worry about the decimals now, or 98. And we've done quite a few of these already. 8 times 8, 64. Okay, 8 times 5 is 40. 40 plus 6 is 46. Bring our 4 up here. 8 times 2 is 16, plus 4 is 20. Okay, 9 times 8 is 72. Bring down our, I forgot to bring down the 0 first. 9 times 8 is 72, so I bring down my 2 there. I add the 7 up here. 9 times 5 is 45. Plus 7, so 45, 46, 47, 48, 49, 50, 51, 52. Bring my 5 over here. 9 times 2 is 18 plus 5, 18, 19, 20, 21, 22, 23. Okay, add it. 4 plus 0 is 4. 4 plus 2 is 8. 2 plus 0 is 2. 2 plus 3 is 5. And then 2 plus 0 is 2. 25,284, is that less than 25,335? It is, so we know that 98 is going to be the number we're working with. Get rid of these automatically. Now we just have to decide which decimal place we're going to use, and let me show you how to do that. So this is the number we get when we multiply 258 times 98. So we basically said how many times does 258 go into 25,335, and we said that was 98. So we're still working on this side of the decimal. And we said that the number when we multiply 258 times 98 is 25,284. Okay? And let's go ahead and subtract that. 5 minus 4 is 1. Again, 8 minus 3, we can't do it, so we have to borrow 1 here. This becomes 2, this becomes 13. How many? 13 minus 8, so 8, 9, 10, 11, 12, 13, that's 5. 2 minus 2, 0. 5 minus 5, 0. 2 minus 2, 0. We bring down this 6. Okay? Now we have to say, we just simply bring that one down. We don't have to include it in our calculations. Now we're saying to ourselves, how many times do we have to multiply 258 by to get 516? If we multiply 250 by 4, that would give us 1,000. Multiply 250 by 2, that would give us 500. So if we multiply 258 by 2, we're going to get 516. So we know that this is going to be 2. Okay? So the answer is D. I'm going to go ahead and delete some of this since I'm going to need the room to work with the fractions that are coming up. So just bear with me as I do that. Go ahead and erase some of it. It's a good thing that this isn't a time test, otherwise I'd be losing time. Now that said, I actually worked in a testing center that administered the TABE. If you take the TABE through a testing center that uses Pearson products, you'll more than likely have a whiteboard and a marker to work with. Okay, you're not going to have you might have pencil and paper, but you might also have a whiteboard to work with. So just keep that in mind. Okay, we have a simple case of long division here. We've already done some division with fractions, so let's go ahead and knock this one out. So we have, I'm going to work up here. Let me redo that. That wasn't too good. And we'll get rid of these as well. So we have 958 divided by 4. Okay. Now we have to take this 4 and see what we can divide it into one by one to get these numbers. Okay. And as you can see, they're all pretty close, so we can't eliminate anything from the get-go. So 4 times what will get you close to 9? 4 times 2 is 8. 4 times 3 is 12, which is bigger than 9. We can't go over 9, so we'll do 4 times 2. 4 times 2 is 8, and we're going to subtract that. That becomes 1. We're going to drop down this 5 and drop down this 8. Now we're saying to ourselves, 4 times what will give us 1? Nothing. 4 times anything's bigger than 1, except fractions. 4 times what will give us 15, or closest to 15 without going over it? Well, 4 times 3 is 12, and 4 times 4 is 16, which is bigger than 15, so we're going to go 4 times 3. Again, 4 times 3 is 12, so we subtract it out. 4, and we're simply going to bring down the 8 again. 15 minus 12 is 3. We're left with 38. So we can see that this is shaping up to be 230 something. Go ahead and get rid of this 240. That's wrong. Okay. Can we multiply something by 4 to get 3? We could if we were using fractions, but that's not how you do long division. 4 times what will get you closest to 38? 4 times 9 will get you 36. 4 times 10 will get you 40, which is greater than 48, so we're going to use 9 up here. Okay. 4 times 9, as I said, is 36. Subtract it out. And now we have 38 minus 36, which is 2. So we're left with a remainder of 2. You take this 2 and you put it over the 4 to get the remainder. So this is technically 239 remainder 4, or 2 over 4. Now 2 over 4 is the same as 1/2, which is the same as 0.5. So we can actually write this as 239.5. That 0.5 is our remainder. Okay? Is that an answer choice? I hope it is. It is. Okay. We did a case like this one already, but nonetheless, it's good practice to do it again. We're taking 494 and dividing it by 3.8. So let's go ahead and get set up again. Again, we got 494, and I'm going to redo that just to give myself some space. And again, this one was 239.5. So we got 494. We're going to divide it by 3.8. Okay. Now, if you take a look at our answer choices, you can see that they are very much different. This will save you tons of time if you can use some common sense to work through these problems. 3.8 times 0.13 is going to give you a smaller number. You're multiplying that 3.8 by a fraction. Get rid of it. 3.8 times 1.3. 3.8 times 1 will give you 3.8. So this isn't going to get you quite to 494. 3.8 times 13. Well, what's 4 times 20? 4 times 20 doesn't even get you close to 400. So we know this one's wrong. 3.8 times 130 is the only logical choice. So without doing any work, you could have eliminated all these answer choices and been done. You need to do that in this test because, as I said, this one is timed. You get 15 minutes for, I think I said 25 problems, so you need to eliminate questions as quickly as possible. So if you get tied up with something like this, just bear in mind that the next question may be something that you can just get off your plate very quickly. Okay, so don't get stressed out about the long ones. You will have opportunities to pick up speed elsewhere. Nonetheless, since we're practicing, let's go ahead and work it out the old-fashioned way. Move this decimal over. Now you're saying there's no decimal over here. What can I move over here? Well, there is technically a decimal there. Move it over here, add a 0, and put it up there. Now I'm going to cheat a little bit because I know what numbers to use since this is 130. I want to first say 38 times what will go into 4? Nothing. 38 times what will get me close to 49? 1 will. And 38 times 1 is 38. Subtract it. 9 minus 8 is 1. And again, we just bring these down. 4 minus 3 is 1. And we got 4, 0. Now, we could say 38 times what will get us 114, or 38 times what will give us 1140. We know it's going to be 30 because we can eliminate the wrong, obvious wrong answer choices. But let's go ahead and work it out just to see if that's correct. 38 times 30. 8 times 0 is 0. 3 times 0 is 0. Drop down a 0 since you're moving to a new line. 3 times 8 is 24. Bring up a 2. 3 times 3 is 9. Add 2, 11. And as you can see, it gets us that 1140 that we were looking for, so we know that this is correct. Okay? And I'm going to go ahead and delete these since I'm going to need the space. I'm going to erase them. Now we're getting to some fractions. And fractions don't go away. I took a linear algebra class where one test problem was literally 50 fractions. And, it was a difficult problem. But that said, let's look at 12, 2/3, 3/8 plus 2/8. So I like to write fractions like this. 3/8 plus 2/8. The rule with fractions is simple. As long as the bases or the denominators are the same, you can add the tops and keep the denominator the same. Okay, so we're going to keep the denominator, namely 8, the same. Simply add the numerator. So this is going to be 3 plus 2. In other words, it's going to be 5/8. Do we have that choice? We do. Okay, 13. We got 4 1/7. Plus 3/7. Now, you might be saying, what can I do here? What is this 4 1/7? This 4 1/7 is what's called a mixed number. We have to convert it to a fraction, simple fraction, to add it to 3/7. To do that, we multiply 4 times 7 and then add 1. So 4 times 7 is 28, plus 1 is 29. over 7 plus 3 over 7. Oops, I don't know why I wrote 4 there. Again, up here we kept the basis the same, 7 and 7, so we could just drag over that 7. 29 plus 3, 29, 30, 31, 32, so we got 32 over 7. Now this becomes a division problem, so we have to reduce it. This is basically saying 32 divided by 7. How many times does 32 go into 7? Or what's the closest we could get 32 to go into 7 by multiplying by what? Well, it's going to be 32. 7 times 5 is 35. That's too great. 7 times 4 is 28. So we know it's going to be 4. Subtract 28. And 28, 29, 30, 31, 32. 4 is going to be the remainder. Again, we put the remainder over this 7. So this is going to be 4 and 4 over 7. That's our fraction. So 4 and 4 over 7. There it is. Okay. Multiplying fractions is very straightforward. We have 5 divided by 8 times 2 over 6. To multiply fractions, you just multiply top across and bottom across and then reduce. So 5 times 2 is 10. 8 times 6 is 48. Okay, you might be saying, well, I don't see that anywhere. Where's that in the answer choice? That's because we got to reduce. Let's divide top and bottom by 2. So 10 divided by 2 is 5. 48 divided by 2. 2 goes into 4 twice. 2 goes into 8 4 times. So we got 5 and 24. Is that there? It is. Boom. Okay, subtracting fractions is just like addition. Again, we got, as long as the bases are the same, you can simply subtract the numerators and leave the denominators the same. So we got 9 over 13 minus 5 over 13. 9 minus 5 is 4. Do we subtract 13 from 13? We don't. We keep the denominators the same, so it becomes 4 over 13. Okay. And as you can see, we're starting to make up that time we lost doing the very tedious mathematics over there. Let's see if I have enough room to do these. Let's see. I'm going to erase some of these so we can have some more space. Because as you can see, we're going to be working with some mixed numbers, and those require a few more steps to complete. So for 16, we have 3 1/2 plus 2 2/6. So let's go ahead and write it over here. 3 1/2 plus 2 2/6. Now I can reduce this 2 2/6 to be 2 1/3, simply dividing top by 2 and bottom by 2. That will give me 2 divided by 2, which will become 1, and 6 divided by 2, which will give me 3. So I'm going to go ahead and do that. Which will make the math simpler in the long run. It will require fewer steps. Again, I'll work it out since I know people haven't seen this in a while. I reduced 2/6 to 1/3. I divided by top and bottom by 2. 2 divided by 2 gets you 1. 6 divided by 2 gets you 3. Okay? Now we can't add mixed numbers like this. First we have to convert to simple fractions, and to do that we multiply this number by this number and add it to the numerator and put it over the denominator. So 3 times 2 is 6, plus 1 is 7, so this becomes 7 over 2, plus 2 times 3 is 6, plus 1 is 7 over 3. Now, unlike the other two we just did, we can't just add top and bottom, our tops, and keep the denominators the same because the denominators are different. So we have to find a common denominator. That is, we have to find a number over which we can put these so we can just do the simple addition of the numerators. So we have to find a number that both of these go into. It turns out it's going to be 6. Again, 2 goes into 6 3 times, 3 goes into 6 2 times. Basically, this is what you do. To make this 2 a 6, you multiply it by 3. What you do to the bottom, you do to the top. So 7 times 3 becomes 21 over 6. To get this 3 a 6, you multiply by 2. What you do to the bottom, you do to the top. 7 times 2 is 14. Okay, now we simply add 14 plus 21 is 35 over 6. Now let's go ahead and check. Do we have our answer over here? We don't. This is a simple fraction, and our answers, as you can see, are fractions. 6 and 5 over 5 is just 7, so that's not it. We know that this is not gonna, we know 35 is not divisible by 6 as a whole number, so we know these are wrong. So we have to work this one out. 6 times 6 is 36, so that's not going to work. 6 times 5 is 30 with a remainder 5. So let me work this out the old-fashioned way, since I'm probably working too fast. Again, you can turn this fraction into long division. And as I said, we're going to multiply by 5. That gets you 30. Subtract it, that gives you a remainder of 5. You put this remainder over that, so 5 and 6, 5/6, which is right here. Okay. Now we're going to subtract a mixed number from a fraction, and again, we can't do that unless they are both fractions. So let's go ahead and write this off to the side, and then we'll work on it. 5 1/3 minus 3 over 4. Again, this is the mixed number, so we have to convert this one. 5 times 3 is 15 plus 1. This becomes 16 over 3 minus 3/4. Again, these don't have the same basis or denominators, so we can't just simply subtract it and be done with it. We have to get these both over a common factor, which is going to be 12. Both go into 12. To get 3 to 12, we multiply 3 by 4. So what we do at the top, we have to do the bottom. 16 times 4, I don't want to make a mistake, so I'll multiply it the long way. 16 times 4, 4 times 6 is 24. Okay, 4 times 1 is 4 plus 2, 6. So we got 64 over 12 minus, to get 4 into 12, we multiply it by 3. So we do that to the top as well. 3 times 3 is 9. So now we're left with 64 minus 9. In other words, this becomes 55 divided by 12. Okay. How many times does 12 go into 55? Well, 12 times 3 is 36. 12 times 4 is 48. So we know we're working with a number bigger than 3. Again, this is a simple division problem. we're dividing 55 by 12. And as I said, 4 is the one that's going to get us closest to 55 without going over. It actually gets us to 48. Subtract it. 5 minus 8, we can't do it. We've got to borrow a 1. This becomes 15. 8, 9, 10, 11, 12, 13, 14, 15. This becomes 7. This becomes 0 because 4 minus 4 is 0. This becomes 4 and 7 over 12. Is that a choice? It is. Good. Fortunately enough, multiplying mixed numbers against fractions is pretty simple. Let's go ahead and do number 18. We got 1 1/2 times 3 over 7. Now, oops, fix that. We cannot multiply a whole number by a fraction. First, we convert the whole number to a fraction and then just multiply across. So 1 times 2 is 2 plus 1. This becomes 3 over 2 times 3 over 7. Again, multiply across on top, multiply across on the bottom. 3 times 3 is 9. 7 times 2 is 14. 9/14. Okay. If this number was bigger than 14, we would have to reduce it, but we cannot reduce this any further. Okay, we're almost done. We have 11 more to go. And some of these are very simple. We're actually past the hardest part of the math computation section. 19, we got 7 over 8 divided by 1/4. Now, if you can multiply fractions, you can definitely divide fractions, and let me show you how. 7 divided by 8, 7 over 8 divided by 1/4 can be rewritten as 7 over 8 times 4 over 1. We just did this example, or a similar example. We just multiply straight across, and we'll be done. 7 times 4 is 28. 8 times 1 is 8. Now we just got to reduce this. Again, I like reducing it using long division. But if you get good enough at mental math, you should be able to reduce it in your head. What's the number we can multiply 8 by? That gets us closest to 28 without going over. That's going to be 3, which will get us 24. 28 minus 24 is 4. We put 4 over 8 since that's our remainder, which is the same as 1/2. And again, I'm skipping steps because if you followed along, you should be getting back into the mode where you can skip a few steps. Okay. Now this is just testing whether you think you can multiply. Excuse me. This is testing your knowledge of multiplication of mixed numbers. I'm not going to do this one. Well, I'll do it, but basically we're going to convert these mixed numbers to fractions, and then just instead of dividing, we're going to flip it and multiply it. So let's see what that looks like. 6 2/3 divided by 2 4/6. Okay, we can't do this yet. They're both mixed numbers. Whenever we work with fractions, we work in fractions and then convert to whole mixed numbers at the end. So 6 times 3 is 18 plus 2 is 20 over 3 divided by 2 times 6 is 12 plus 4 is 16 over 6. Again, we're not quite there yet. 20 over 3. Instead of dividing, we're going to multiply and flip these, invert them. 6 over 16. Now you might be saying this is a lot of work. I don't want to do all this work. 20 times 6, 3 times 16, that's going to take me forever. Well, let's reduce it. 3 times 3 goes into 3 one time, 3 goes into 6 twice. So that should help you. This gives you, and you can do it with 16 and 20. I'm just not going to do that right now because I'm afraid people won't follow. This gives you 40 over 16. Now we can start turning it back into a mixed number. So again, we got 40 divided by 16. Let's see what our answer choices are. 6 over 2, we know that's not going to be right. 16 times 3, let's see what that gives us. Does that give us 40? 16, 6 times 3 is 9. Gives us 49, so we know that's too big, so we know it's going to be 2. 16 times 2 gives us 32. Subtract it. Borrow 1, that becomes a 3. This becomes 10. So this becomes 8. Does 16 go into 8? It doesn't, so this is our remainder. Again, we can write that as 8 over 16, or simply 1/2. So this is 2 1/2. Okay, I think we're done with fractions. Let me go ahead and clean up our workspace by erasing some of this. I think I've been making weird noises during this this session, so please forgive me. Okay. 10% of 16. We're basically trying to figure out what over 16 is going to give us 10%. 10 over 16 is more than half. 16 over 16 is 1. 1.6 divided by 16 will get us 10%. Now, in case you didn't know how to do that without just by looking at it, you could do it like this. 16 times 0.1, and again, 0.1 represents 10%. And again, we're going to move this over. We moved it over 1, so we're going to have to add that back on. 6 times 1 is 6. 1 times 1 is 1. Bring our decimal place back over. 1.6. Okay? 70% of 32. Again, 32. This is basically asking you what is 70% of 32. So we're going to take 32, multiply it by 0.7. Again, just as we did over here, move this 7 over, and we moved it over 1. We're going to have to move it back to the left when we're all done with our work. 2 times 7 is 14. Bring the 1. 7 times 3 is 21 plus 1. That gives us 22. Bring our 1 over. So 70% of 32 is 22.4. And again, you could have eliminated these right off the bat, and you would have had to choose between those two. 20 minus negative 3. You have 20 minus negative 3. Whenever you have double negatives like that, they become positive, one big positive. So this is 20 plus 3, which is just 23. This one is just testing your knowledge of, please excuse my dear Aunt Sally. That is your order of operations, parentheses, and the order of operations, in case you didn't know, are the order in which you solve problems like these. If it's not readily apparent, you start with what's in parentheses, then you work on exponents, then you work on multiplication and division, and then addition and subtraction, and these are actually considered equal. If you just have addition and subtraction, in other words, you work from left to right. So in this case, we just have negatives and positive, so we're just going to work from left to right. Negative 6 plus 5 is negative 1, plus 8 gives us 7. Okay. Blank percentage of 50 gives us 40. Okay. So this is basically saying what percentage is 40 over 50. So let's go ahead and do that. 40 over 50. We can cross out these zeros and turn it into a division problem. I did that wrong. Doing 4 divided by 5. 5 can't go into 4, so we bring a 0 and bring up a decimal place. 5 goes into 48, so that's 0.8 is the same as 80%. 6% of what gets you 36? So it's 0.6 times some number gets you 36. What I'd like to do to make it nice and easy is just multiply all these by 0.6 and see which one works out. So I'll start randomly with 0.6 or 600. 600 times 0.6. Again, I'm going to move this over 1 and then I'll add it back in later. We got 0. 6 times 0 is 0. 6 times 0 is 0. 6 times 6 is 36. Okay, 1 decimal place. Oh, I made a mistake. Should be 0.6 is not 6%. 0.06 is 6%. So actually I had to move this 2. So 1, 2, it is 600. Sorry about that. 27, 6x plus x. You can rewrite this to be 6x plus 1x. These are variables. 6 times variable x, 1 times variable x. You can simply add those to get 7x. Now let's say you had 6x plus 1xy. This would be your answer. You can't add 6x plus 1xy because this 1 times x times y is totally different than just 1 times x. Okay? In this case, the x values are always going to be the same. Okay? In this case, we don't know what the y value is, but it changes the x value. Okay, so as long as you have the same things, you can add them together. Negative 7ab minus 2ab. Again, these are the same, so we can subtract them. 7 minus 2 is 5ab. Now, if this was 7abc minus 2ab, we couldn't do anything because this is abc and this is just ab. Those are not like terms. We cannot touch. We cannot just simply subtract them. 29, we got 3 to the third times 3 to the second. You might be saying to yourself, wow, I forgot how to do that. Well, that's fine. 3 to the third is the same as writing 3 times 3 times 3. We got a multiplication sign here, so just bring it over. 3 squared is the same as 3 times 3. So we got 3 times 3 times 3 times 3 times 3. In other words, we have 3 times itself to the 5th power. Okay? Again, this is 3 to the third, and this is 3 squared. Okay. We all know what 100 times 4 is. That would be 400. So we can get rid of this. Now we have to decide what it's going to be. Is it going to be positive or negative? Well, when I went to school, they taught us a negative times a positive is a negative. So it's going to be this. And let me give you the signs chart because you may need it. Positive times a positive is going to result in a positive. A positive times a negative is going to result in a negative. A negative times a positive is going to give you a negative. And a negative times a negative is going to give you a positive. Okay, so as you can see here, we have positive 100 times negative 4, so we know our result's going to be negative. Okay, so that's it for this section. If you were taking the real thing, you would have to work much more quickly. As I said, the best thing you can do is to practice the problems and figure out what you struggle with, and then work on that, because as I keep saying, in order to do well, you're going to have to work very quickly on this section. If you liked the video, please give me a thumbs up. If you want to give me feedback, send me a message or put a comment in the comment section below. But on that note, I will go ahead and cut you loose.